So how a diode is formed, the formation of a diode, which is a better conductor, actually what happened, holes are providing spaces for the electrons to move. So both are having a same conduction rate. Like holes are like vacancy of electrons. So if electron is available, electron can jump from one hole to another. So both are having a same conduction rate depending on how much it is added. The intrinsic and the extrinsic semiconductor, in an intrinsic semiconductor we don't add impurity, like it is already the structure of a semiconductor. It's conducting electricity because of production of electron and hole by itself because of heat or light. That is intrinsic. But in an extrinsic semiconductor we add impurities, so we increase the conduction that it start to conduct more. But semiconductors are not used like we use a p type or a n type. We use them together. So when we join them together, so we have a p type and n type junction, means we combine the p type and n type. Say the left hand side we have p type semiconductor, and on the right hand side we have n type. The p type semiconductor, it's having a group 3 element like boron is there bonded with silicon, and there's a hole. Vacancy is there, that electron can be there. So there's a hole available and then silicon. And the structure continue. What will happen in n-type semiconductors, n-type semiconductor like group 5, say, let's say arsenic is there or phosphorus is there. And there's an additional electron available. So when we mix the p-type with n-type semiconductor, as a result, what will happen? The electron which are additional in the n type will jump and go inside and take the space in the holes, like combine with the holes. Hole means like there's a space available for the electron. So as a result, because this molecule is losing electron, so if molecule lose electron, what should be the charge? Positive or negative? The n type is losing electron. What should be the charge? So it will be positive. So this will get a positive charge. And what will happen, because this group of molecule, the structure gain electrons, so what will the charge? The charge will be negative. So as a result, when a p type and n types are mixed together, the molecules, the structure on the n side will get a positive charge because it is losing electron, and the structure on the p side is getting a negative charge. So as a result of this electron transfer, so I'm just drawing the holes here instead of drawing the whole structure. Like I'm just giving an idea that these circles are representing holes. And these electrons, there are electrons as well. I'm just drawing electron. I'm not drawing the whole structure of the molecule again. So n-type is having majority of electron. There are holes as well. Look, there are holes. And here also there are electrons as well. But p-type is having majority of the holes and n-type is having majority of electrons. So as a result, what will happen when these electrons enter the hole? So this side will get a negative charge. As the electron jumps into the hole, the side will get a negative charge. And the molecules which are losing electrons, they will get a positive charge. So this will get a positive charge. So between a p and n type structure, there will be a layer of the positive and the negative charges. What we call this layer, we call that as a barrier. So p type is having majority holes and n type is having majority electrons, and between the p and n type, it create a barrier. And this barrier, the width of this barrier or the wall will be fixed or finite according to the element. which elements are used. Why all of the electrons cannot mix with a hole? Example, why this electron cannot mix with a hole? Because as a barrier is formed here, this electron want to move, like it is attracted towards the positive and repelled by the negative. So as a result, this electron is not able to transfer or jump the barrier. So means when once the barrier is formed between the p and the n type, the electrons are not able to move and cross the barrier, so the electron will stop. And when this electron will stop, the p type is represented by a triangle and n type is represented by a line. So what we call that as a diode. So actually a diode is a combination of p and n. When p type semiconductor combined with n-type semiconductor, there is always a barrier between them, barrier of the charges, positive and negative charges. And what we call this, we call that as a diode. So combination of a p and n-type is known as diode. The horizontal lines are representing the wires, connection wires. This is a circuit symbol for the diode. So whenever you are using a circuit symbol of a diode, you use this. So the p type is having majority of the holes are there in the p type, and n type majority of the electrons. These electrons jump. When they jump, one side will get a negative charge, one side will get a positive. So between the p and n type semiconductor, there is always a barrier. That is why when we sketch a graph for IV, so when we sketch a graph for IV, what will the shape of the graph you will see for a diode? If there is a current on y-axis and there is a voltage on x-axis, or current on y-axis and the voltage on x-axis, the shape of the graph of a diode is like this. How we will explain that why the diode initially it is not conducting? We can explain in terms of the structure of a diode. Like say you have a diode and you connect this diode with a supply, which is having a voltmeter to measure the voltage, an ammeter. It can be before or after to measure the current. Now I will draw the internal structure of a diode. So what is actually a diode? It's a combination of P and N type. P means majority of them are holes and N means majority of them are electrons. And between the P and N, because some of the electron jump, reverse, Imad, your question is good, but just I will explain the forward current and then I'll explain the backward current. Like the question which you ask is, it's also I will explain in a backward direction. But first, I'm just explaining the first half, and then I'll explain the reverse half as well. So you connect a battery, and we have a voltmeter, and we have an ammeter. Now, what will happen? The what is the direction of the conventional current? And there's a barrier here. What is the barrier? The negative charges here, and the positive charges, and they will block the electrons to move from one end to another. Now, when we increase the voltage here, if we have a variable supply, how the charge is coming, I just explained the idea of the charge formation. In a p-type, we have majority of the, in a p-type, we have majority of holes, and in a n-type, we have majority of electrons. But when some of the electrons jump and combine with the holes, so the molecule which are losing the electron will get a positive charge, and the molecule which gain electron will get a negative charge. That's how the charge came. So always in a diode, the center of a diode is always the barrier. Now what will happen when you increase the voltage? Like let's say numbers are there, say 0.1 is there, 0.2 is there. 0.3 is there, and so on. So when you apply a voltage of 0.1, I'm showing in terms of electron flow. So negative terminal electrons will move. This electron need to cross the barrier. For if it is made up of silicon, this electron needs 0.7 volts. And for a germanium, this electron needs 0.3 volts, depending on the type of silicon, the diode, the material this diode is made up of. So when we increase the voltage, the electrons start to move, but like let's say we apply a voltage of 0.1. When we apply a voltage of 0.1, so this electron does not have sufficient energy to cross the barrier, so it will stop here. So what is the current? What is the reading on ammeter? The reading on ammeter will be zero because the current is the flow of the charges. There is no flow of the charges. Then we increase the voltage to 0.2. When we increase the voltage to zero point 0.2, again electron start to move, but it's not able to cross or jump the barrier because minimum energy it need is 0.3 joules per coulomb, but we are not supplying that. So that's why still the current will be zero. So when we are sketching a graph for a voltage, so when the voltage is 0.1 and we have on y-axis we have a current. So when the voltage is 0.1, the diode does not conduct electricity. When the voltage is 0.2, diode does not conduct. When the voltage is 0.3, if it was made of germanium, so when it is 0.3, then only the diode start to conduct, allow the electrons to move. So that's why at 0.1, no current, 0.2, no current, but 0.3, the current start to flow. And then when we increase the voltage, the current will also increase. That's why the shape of the graph for a diode, when it is positive is connected to P type and negative is connected to N type. So initially it will not conduct because of the barrier potential. But then it start to conduct because the voltage or the energy which the electrons carry is more than the barrier potential. That's why it is able to conduct electricity. Is it clear? Variable power supply means we can change the voltage of a supply, that is called variable power supply. Anyone having a doubt or a question in the forward by current, like if we connect a diode in this manner? So for diode, always there is it's not start to conduct from the beginning. It will only conduct once the voltage is more than or equal to the barrier voltage. Usually, if the diode is made up of silicon, this voltage is 0.7. But if the diode is made up of germanium, it is 0.3. Conventional current is our assumption that there's a current from positive to negative, but in reality, electrons will flow. That's why I use the concept of electron to explain the internal structure. But when we draw the conventional current, how we'll draw the conventional current? Conventional current is always opposite to the direction of electron flow. Internally, there is no conventional current. Conventional current is just an assumption that the current is from positive to negative. So if we have a diode, if we have a diode and we connect to a battery or a supply, a variable supply, means we can change the voltage of the supply. And we have an ammeter. So if we want to show a direction of current, we always draw conventional current. So that is what we do, conventional current. So when we are increasing a voltage, the current will not increase because the barrier is not allowing the charges to flow. And then at a certain voltage, the current start to increase. And what is the resistance of a diode at this point? The resistance of a diode is infinite. Why it's infinite? Because the resistance is a ratio between voltage and current. The current is zero. So voltage divided by zero, what I will get? I will get infinity. Yeah, conventional current is just an assumption to explain that the direction of the current is positive to negative. But the electron flow is actually the one which happen in reality, electron flow is there. But we always, whenever we draw electrical circuit, we draw the conventional current. So when the current is passing from the side of the P type, the conventional current, in that case, the diode allow the current to pass or in a state of on. But in internally, it's not conventional current. Internally, that the electron flow is there. Is it clear this part? You always take a conventional current whenever you want to draw a direction of the current in the circuit. You always take a conventional current. But because I was explaining internal structure, that is why internally there is no conventional current. There is, in reality, electron flow is there. If we connect this other way around, like example, we have a p type and we have an n type. We have majority of the holes here in a p type and we have majority of electrons in n type. So some of the electron jump, so this will be negative charge here on this side and the positive charge on the other side. And now we connect a diode other way around. Like we connect with a P, we connect a negative terminal, and with N, we connect a positive terminal. So the diode does not conduct electricity other way around. If you remember the graph of a diode, like the diode, when the direction of the current, conventional current is in from P type, it will be in a state of on, like allow the current to pass. But when the direction is from the side of N, it is in a state of off. But how we explain in terms of electrons that what happened in terms of electrons when we connect a positive terminal here, when we connect a positive terminal, so this positive terminal will attract the electron. So instead of electron flow out, these electrons start to move towards the positive terminal. When these electrons start to move towards the positive terminal, the molecules in the structure are losing those electrons. When the molecule lose or lost electrons, so there will be a positive charge. So as a result, what will happen? The positive charge will increase because the electron are being lost by the molecule as it is attracted towards the positive terminal of the battery. And the negative terminal, from a negative terminal, electrons will move. So as these electrons will move, they combine with the hole. So when electrons combine with the hole, as a result, what will happen? There will be negative charge. So when we connect the diode other way around, the size of the barrier is increasing instead of diode allowing the current to pass. Like charges are not able to flow from one end to another. From N type, electrons are removed, and towards the P type, electrons are added. So as a result, the barrier width is increasing. When the barrier width is increasing, as a result, we don't observe any flow of the charge through the diode. So we say the current is zero. So when we sketch a graph for a voltage and a current, we have current on y-axis and voltage on x-axis. So when we were connecting in this way, like this is a part, when P is connected with a positive and N is connected with a negative, first we need some voltage to cross the barrier. Once we have a sufficient voltage, then the conduction occur. This has happened. But if we connect other way around, like we change the terminal, positive and negative. So this is a diode and we change the other way around. So as a result, what will happen now? That the diode does not allow the flow of the charges, the conventional current to flow. So, or the electrons to flow. So as a result, we'll have zero current even we are changing a voltage. So other way around, the barrier width is increasing. That's why one way the diode allow the current to pass and another way it does not allow. Why the electrons are not able to flow? Because like from a positive, the positive terminal is attracting the electrons. So electrons are going out. So the molecules are, because most of the electrons are in this region, so these molecules are losing their electrons. When they are losing the electron, the net charge or the net positive charge on the N type is increasing. And same thing, electrons, when we increase when the electrons are connected to a p type, these electrons are combining with the hole. So when they combine with the hole, overall negative charge on the other side is increasing. So so actually what happened, like here we'll have holes and here we have electrons, but there is no movement. Why there is no movement? Because these electrons from here, Why they're not able to move? Because mostly negative charge. Like charges repel each other. So because of the repulsion, the electrons are not able to move through the barrier, across the barrier. And until there will be a very high voltage, which we call avalanche, which break down this barrier and the diode conduct electricity. But before that, most of the diode burn. Because if the voltage is too high, because of the heat energy, the diode will burn. So the question is, why can't they go from negative to positive? From why they're not able to cross? Because these negative charges are repelling the electrons. So we have